So don't worry about what you write. So
Right.
it should not be like, okay, there is a stricter definition. Yes, I have to
Yeah.
adhere to this.
Yeah.
There is no other way. If I put
Yeah.
something else, I will score a 0. It's not like that. It's
Correct.
not. Trust me.
Yeah.
Even if, let's say, if your professor or if your lecturer does do that,
Yeah.
you can still challenge it.
No,
I'm telling.
I'm
I'm
not going
not
to
kidding
challenge
you.
anything. I just want to pass. Yeah.
No.
Yeah. No, they are
No,
okay types, huh?
because
These teachers, this is a private college, no, not a government college. Autonomous and all that. Everything is in their
my
hands
point
only.
is,
Yeah.
my
Yeah.
point is, it's
Yeah.
not a stricter definition as such.
Yes.
Okay,
Yeah.
so it is basically what you have to understand is
Yeah.
data structure. Yes, this
Yeah.
is, as I said, this is a data structure, right? You can
Yeah.
give the example of array.
Yeah.
Now, is uh, uh, data type, is array also, can array also be called as a data type? Some people will call it as a data type,
Yeah. Yeah.
Do you know? Some people will actually call it,
Oh,
entertain
okay.
to call it as a data
Okay,
type.
got it, got it. Yeah.
Okay, it's just
Yeah.
a complex data type.
Yeah.
Okay, we
Yeah.
can say it's a, or the correct word to use would be array is a composite data type. Do you agree? Array is a
Yeah.
composite
Yeah.
data type.
Yes, yes.
Simply, you can just use this word also. This is a
Yeah.
good word for
Yeah.
defining data structures. It's a
Right.
composite data. It's something which consists of composite data types.
Yes.
Okay.
Yes.
So either in terms of more numbers of
Yeah.
the same data type,
Yeah.
or it can have multitude of data types.
Yes.
Right?
Yes.
So that's a data structure basically.
Yes,
Okay.
sir. Yeah.
That's a more appropriate definition. Yeah.
Okay.
What I've stated now.
Okay.
Okay. So that is abstract data type. Yeah. Encapsulation is one. The benefit. Implementation. Yeah. The operations as such which you can do.
Yes.
Right. So that is one.
Yeah.
Reusability.
Yes.
So here's the thing.
Yeah.
By creating the structure outside the main, right? As such,
Yeah.
can I reuse it again and again? Like I create, say, let's say in the next line itself,
Yeah.
I create another person, P2.
Yeah.
Could I do that? I could do that.
Yeah.
Reusability is also, of course, it's of course a very trivial benefit, but yeah, it is also, of course, a benefit. Okay,
Yeah.
you could say that.
Yeah. Yeah.
Easier implementation / maintenance. Okay,
Yeah.
easy to maintain as well.
Yeah.
Simple, just write few stuff. Okay, so majorly they will see 1 or 2 points. Yeah. Okay.
Now, abstract data type, and what is a non-abstract data type?
No, so that's what I'm saying. So
Yeah.
non-abstract data type
Yeah.
is one
Yeah.
which would really not be concerned with any sort of operations.
I got it. You already told me. Yeah.
So, okay. Next question they are asking is a linear data structure,
But
and give 3
abstract
examples.
doesn't really describe, no? That just because there are operations, it is called abstract. But abstract actually doesn't mean, abstract means something which is not tangible.
In reality, abstract means something which is not tangible.
So
in reality,
so everything.
no, it's actually something which is tangible, right? What is abstract? What is the meaning of abstract?
Which is not tangible. Something like abstract means we are thinking of an idea which is abstract. Like if you say weight.
So if you say, of course, if you put it that way, But that is in English. In computer science, it's totally something different. Yeah.
Okay. So in computer science, abstract means when you can do operations on it. That is abstract.
Right. So
it doesn't.
Data structures. Now can be based on how they are arranged, can either be linear, or non-linear. Data structures. Again, this classification I'm making based on how they are arranged. What do you mean arrangement? What is linear? What is a linear array?
An array is linear because it is straight, it is continuous, and it is one after the other.
Simple example, array.
Yeah.
Okay, so what's a non-linear? Tell me.
Non-linear would be a stack probably, because
No.
Okay, non-linear would be linked list.
No.
Okay.
I say linked list looks like this. Okay.
Yeah.
I say linked list looks like this.
It is not continuous. Like you can jump. You don't have to go slot 1, slot 2, slot 3. You can jump.
Not really.
See. Okay.
Suppose see the structure
I know. It is a node and all, na? Node. It is like a
Suppose
tree. It is like a tree.
tree, very good. Tree,
Yeah.
very good.
Yeah.
So where you have a root
Yeah.
or a parent node, it's also called root node or a parent node.
Okay.
Okay.
Yeah.
So a parent will have two child nodes.
Right.
So this is two child node, and every child will again have incur two child node.
Yeah.
So this is basically a non-linear structure.
Yeah.
Okay.
Yeah.
Because it makes traversal difficult. See, if you from this parent, if you go in one line, okay, you go to here, let's say, and then from there again I choose another line. So you are in a particular branch, if you see, right?
Yeah. Yeah.
Which does not allow you to traverse the whole thing.
Yeah.
Okay.
Yeah.
Opposite of a linear.
Yeah.
Okay. So basically, this is what makes it non-linear. Okay.
Right.
So the way data is arranged.
Yeah.
So the way data is arranged, kind of makes it either linear or non-linear.
Yes.
Okay.
Yes.
Yeah. Three examples. Yeah, the three examples which you have actually given, I would give as the examples for linear data type.
Okay.
Array, stack, linked list.
Okay.
Queue also.
Yeah.
Okay.
Yeah.
So those are
I
linear.
understood.
Okay.
Yeah.
Non-linear data types and give three examples, right? So this is tree.
Yeah.
Okay.
Yeah.
Graph. There is a thing called graph.
Yeah.
Okay. Let's say if I draw something like this. Wait.
That is also non-linear.
Okay. What is this? What do you think of when you see something like this?
This is non-linear, of course.
This is, first of all, I will name it. It is called as a graph.
Okay.
Where do you see a graph? My question is, where do you see a graph?
You mean it is a graph that we use in geometry?
Something like in real life. Where do you have such sort of connections, maybe?
This is like atoms and molecules.
Very good.
Okay.
And
carbon. These are the carbon atoms,
also
carbon molecules. Yeah.
Something like a subway network. So does it look like a subway network?
Right.
Line.
Right.
Okay. Also, yeah. Your example is also correct. Graph.
No, subway but it would be subway network would be in one dimension, like P or Q, P axis or X axis or Y axis, but not Z axis. Because it wouldn't be going upwards.
Where maybe,
yeah.
No. Where maybe network of the metro line is not very fully expanded. It does look like that. I know what you're saying. So it looks like this.
Yeah.
And then maybe it comes like this.
No, you're right. It can be a network also. Yeah. Because in Mumbai we have the Western Railway, Central Railway, Harbour Line. So they form networks. Yeah.
So in Bangalore, no. So you actually have, there is a pink line.
Right.
Okay. Right. And then there is a green line.
Right.
Okay.
Right.
So this line goes like, the green line goes like this.
Yeah.
And the pink line continues like this.
Right.
Yeah.
Right.
And here in the green line afterwards, at Benningalli, like you get another line called as yellow line. Yeah.
Here we have red and blue. And some other lines. I forgot the this thing, yellow line and all. Some colors are there.
So this is non-linear, right? Of course, non-linear. Yes.
Yes.
So trees.
Yeah.
Graphs.
Okay.
Okay.
Yeah.
What else?
So graphs are only in two axes, no? X and Y axis, not Z.
You could also sometimes create an orientation for a graph.
Okay.
So the thing is, it might not necessarily be at some specific angles. You could also create some orientations for the graph, right?
Yeah.
Okay. As you said, so like molecules and atoms. Molecules and atoms might actually look perfect, but So it does not necessarily need to have a certain orientation.
And trees also in two dimensions, no? X and Y.
Trees also too. Oh, you mean like X and Y? Okay, in sort of this dimension.
X-axis, Y-axis on the graph, no? X-axis, Y-axis. Right. It is not in Z-axis, no? Means it is not coming towards us, no? That is what I'm saying.
Have you seen in any science museum the model of a like atom?
Yeah.
So especially there is a very beautiful structure which is.
What I mean is it 3D? Is it 3D or 2D? That is what I'm asking.
Right. Buckminster Fullerene, right? Buckminster, just type about this.
Okay.
The 3D structure of Buckminster Fullerene.
Okay.
You will see it's such a beautiful graph. There are 60, I think I suspect 60 sort of atoms, 60 total. Everything of equal size. Everything is like small beads.
Okay.
So each like well connected. Buckminster Fullerene. Just maybe type that.
So, but this
it's a very beautiful 3D structure.
Okay, so I want to ask you, so in data structures like tree and graph, is it 2D or 3D?
Could be possible. 3D could be possible. That's what I'm saying. It's not up to us. The implementation could be in multiple ways.
Yeah, right? Means in the RAM you can store it as 3D also?
In the RAM you may store actually in the RAM, right?
Yeah.
So that's just really data. It's just like a registry. RAM is just like a registry. Nothing to visualize over there.
No, so then this tree and all is in RAM only, no? Tree and graph is in RAM only, no?
Certain memory for each of the nodes. Tree, how do you locate a tree? As such, thinking about it, I have seen a 3D graph actually so far, but I haven't ever seen a 3D tree, to be honest. That's one thing I will say.
Okay.
One more thing is, as such, what information do you think needs to be stored in the memory about a tree? So the parent node and its connection to the child nodes. So which are the child nodes? That connection detail, and of course the child node values also, right?
So all this all this is stored in not in static memory, in RAM only it is stored, no?
It's all stored in RAM. Yeah. Okay. Example. So is there a third example for non-linear data array? Okay, let me think. All this is in RAM. See, mind you, unless you do some kind of a file transfer, and make a static file.
Yeah.
All this is just in RAM. Okay. Trust me. So, okay, let's see. A tree is one, right? A graph is one.
Yeah.
Okay.
Non-linear.
Price. Yeah. Okay. Price is a tree algorithm designed for text data and is used for applications like spell checking, finding words in a dictionary. Okay. Okay. There is one more, binary tree. Achha, but binary tree is just again a tree only, right?
Okay.
Yeah. Trees, graphs, heaps. Achha, heaps. Heaps. Yeah.
Okay. Heaps are also non-linear structures, data structures.
Data structures. So because you wanted 3 examples, right? So I'm giving you the 3 examples.
Right. I got it, sir. I got it.
Yeah. Okay. So next, what do we have? Next question that we have is, what are the basic operations performed
on data structures? So basic operations performed are arithmetic, no? Arithmetic operations?
Just the indexing. Just the indexing. So this is where you have to be careful.
Okay.
This is where you have to be careful.
Indexing.
If I create a data structure, just indexing, that's it. If I create a structure, some name I will give it, okay?
Yeah.
And I have character, let's say A1, character A2, okay, and then maybe a character array also, right? Let's say I can store an array also.
Yeah.
Okay. And then I close this structure. So this is some structure, let's call it X code or something.
Yeah.
Okay. What could you at best to do? Maybe you could access the elements, right? Could we do any operations on it? Because with characters, right, you won't be able to perform arithmetic.
Yeah.
That we won't be able to perform. Okay.
But so the value of the character could be in integer. Value of the character could be in integer.
Right. Okay. Reassignment. See, what all things you could perform. See, I will tell you. Basic operations which you can perform is, you can reassign the character. You can do that. Say, for example, in one line I gave A1, let's say. Okay. The structure. So the sum structure dot A1 equal to the value 8. Right?
Yeah.
Okay. Oh no, it's not like, okay, oh my god, I've given 8. I can't change it anywhere else now. No, it's not the end of the world. I can give the same structure dot A1. I can just reassign it to maybe 9. Get the point?
Yeah.
So reassignment is of course possible.
So, okay. but sir, yeah, we can give this
basic operations you can do.
But basic operation we can do like A1 plus A2 we can't do here.
Not with characters. See, can we add 2 characters?
No,
Yeah,
we can't add age and gender and all. We can't add. No, age is integer. Sorry, we can't add gender and gender. Even if the gender has an integer value.
See,
I can't hear in between. It's gone off. The voice is gone off. Yeah.
plus A2. Yeah. See, you can value and this value for B, which enables it to be added.
So your voice is going off in between. Now I can't hear at all.
Hello?
Yes, sir.
Can
Now
you
I
hear
can
me
hear.
now?
Now I can hear.
Sorry. I think, this is some data. Yeah. So what I was saying was, you can't add characters, right? See, I'm doing A1 plus A2.
Yes.
Could we add characters? No.
No.
You can't.
Because
There is
character
no
is
value
like
associated. There's no value associated with character, right?
Yes.
You get the point. There is
Yes.
no value like
Huh.
A is for 5, B is for 6.
Yeah.
Adding 5 and 6, it should get 11. No,
Yeah.
you can't do that. So only you can only describe the basic operations,
So what you
which
wrote
is like reassignment.
so what you wrote A1 is equal to 8 is really not possible. It is just theoretical.
Like A1 is equal to 8. Okay, let's say A2 was 9. I cannot add A1 and A2.
No, but
which would be 17.
Because it is not, A1 is actually not equal to 8. A1 is equal to male or female if it is gender. No, it doesn't really have an integer value. Like in which case would a character have an integer value?
Only in the case that I put single quote around it, right?
Yeah, means in the real world it cannot have an integer value.
Then also there is no value. And also A1 is the value of A1 is actually 8. No, that we can't say.
Because if it is gender, then A1 is male.